Hi, my name's David, and I want to tell you about a method of drawing conics that are written in standard form that I like to call the method of boxes. The way it works is for each of the non-singular conics, you draw a box, and your conic either lives inside the box, outside the box, or through the box. I'll start with the ellipse. The ellipse lives inside the box, and I'll show you how that works. The equation of your ellipse in standard form looks something like this. X on A squared plus y on B squared equals 1. So what we're going to do is we're going to use these numbers A and B to draw a box. There's my x-axis and my y-axis. And I'm going to mark the points A and minus A on the x-axis and the points B and minus B on the y-axis. And draw a box that goes through those points. Now, my ellipse lives inside this box. I'll show you where it is. There, touching the edges of the box at the points where it crosses the x and y axes. So your ellipse lives inside the box. Your hyperbola lives outside the box. The standard form of your equation for a hyperbola looks something like this. X on A squared minus y on B squared equals 1. And we're going to do exactly the same thing that we did with the ellipse. We're going to draw some x and y axes. We're going to mark the points A and minus A on the x-axis. We're going to mark the points B and minus B on the y-axis, and we're going to draw a box. Now the hyperbola actually lives outside this box. It touches the box at the places where the box crosses the axes, and it moves outwards from there towards its two asymptotes. And the box tells us where the asymptotes are too. The asymptotes pass through the corners of the box, like this. And as I said, the hyperbola lives outside the box. We just have to figure out whether it points upwards, downwards, or left, right. Let's just have a look at the equation. To figure out where it would cross the y-axis, I would set x equals 0. So let's have a look at that. Then I'd get no solutions for y because I've got negative equals positive. So this hyperbola doesn't cross the y-axis. So my hyperbola must be here. It touches the box on the outside at the places where it crosses the x-axis. And there it is. Of course, my hyperbola might point the other way, and I'll draw a picture of that one too. So the equation of my hyperbola might be minus x on A squared plus y on B squared equals 1. And we'll do the same thing we did last time. We'll draw x and y axes. We'll mark the points A and minus A on the x-axis and the points B and minus B on the y-axis, and we'll draw a box. And the asymptotes of the hyperbola pass through the corners of the box. and my hyperbola lives outside the box, meeting the box at the places where it crosses one of the axes and heads towards its asymptotes. And which axis does it cross? Well, let's have a look. What happens if we set x to be 0? Then there is a solution for y, and so therefore it must cross the y-axis. So it must meet the box at the places where it crosses the y-axis. And that's the shape of a hyperbola. Let's have a look at the parabola now. Your parabola lives through the box. You can write the equation of your parabola like this. Y on B is x on A squared. That's not the normal way of writing the equation of parabola, but the nice thing about this is it looks very much like the other equations for the ellipse and the hyperbola. It's just that one of them isn't squared. So we're going to do the same trick as we did last time. Let's mark the points A and minus A on the x-axis and B and minus B on the y-axis and draw a box. Now your parabola passes through the box. It passes through two of the corners of the box and the center. This parabola, since it's more or less y equals x squared, will be upwards facing. So it's going to do this. Of course, there's a few more options for how a parabola could pass through that box, and I'm going to draw all four of them. Firstly, your equation could look like this instead. Y on B is minus x on A squared. We'll do the same thing we did last time. We'll mark A and minus A on the x-axis and B and minus B on the y-axis and draw a box. And my parabola passes through the box. This parabola is more or less y equals minus x squared, so it must be facing downwards. Okay. What if I switch the x's and the y's? What if I had x on A equals y on B squared? We'll do the same thing as always. Mark A and minus A, B and minus B, and draw a box. And this time, points in this direction. And finally, there's one more version. The last version is it could be x on A equals minus y on B squared. So we'll draw our axes, we'll mark in A and minus A and B and minus B and draw a box. And this time the parabola faces this way. And that is how to draw conics using the method of boxes.